Hello people. February was a pretty busy month for me. I did not make any assets, levels, or new mechanics for my game, but I spent this month organizing the engine and making compilation tools. This episode might be not that interesting for most people, but if you still want to know what I did this month, here it is. So let me explain you how things worked before I started reorganizing my workflow and what I did to improve it. This is how my folder with the game used to look like. You can see a lot of files, some of them are even without an extension, and there are also copies of these files. If you look into folders, they are not any better. Before I decided to organize this mess, I had the next mindset. It's going to be much faster to do something that takes 5 seconds of your time manually rather than spending hours automizing it. Moving files around folders, renaming them, and running executables to compile them did not sound that bad to me at this period of time. But after a long break, I realized how wrong I was. Having a pleasant workflow might actually improve my performance and let me concentrate on more important tasks without any distraction from tiny ones. In addition, I don't really know how much time I will spend on doing these small actions in sum, so spending some time automizing them may end up saving me time on the long run. So the first thing I did was organizing the folder by planning the whole folder structure. I wanted everything to be where it belongs. Everything relatable to compiling exe would still remain in the root folder. I also allowed log.txt file to be in there because I will be using it a lot to debug the game and understand the cause of the game's crashes. Also, the final games file will be there after its compilation. The assets folder will contain all data that needs to be added to the executable file. The objects folder will contain objects that will be compiled into exe file. The headers folder will contain header files so code from my game can interact with the engine or refer to assets only by using their names. The source folder will contain source code of the engine, game, and GUI, while tools will contain all tools I will be using for making this game. Their source code will be stored in this folder too. So, after making this structure, it's time to make a set of tools to work with it efficiently. So let's start with compiling the engine. Engine is a part of the game that handles a lot of low-level stuff like handling window events, rendering the image, loading and rendering the sounds, reading input, etc. I have an executable file that compiles the engine from the source code into engine.o file and places it into objects folder. Also, engine has the header file so that the game knows how to communicate with the engine without caring about low-level implementations. Then the game compiler uses this object file and source code from the game's source folder to compile the temporary exe file. Yes, that's right, the temporary exe file. To make the full exe file, we need to take care of another step, the data compiling. The data compiler analyzes the assets folder and merges all files in there into one single file called data.o. It does it by labeling each object with 3-byte label so the engine can understand what type of object it is working with and sends it to the right function, while also knowing the object size before going on to the next one. In addition, it generates assets header file that contains all IDs or data offsets, so it's going to be easy to tell the engine what data to use just by writing its path and name to it, where backslashes are replaced with underscores. Extension names are also ignored. After it has finished merging all data into one file, the game compiler creates a copy of the temporary exe file and appends the data to it, but just doing that is not enough. When the game is launched, it tries to initialize game assets by reading the exe file it was launched from. All it will see is a mess of bytes and it won't be able to recognize where it is supposed to start reading the data. To solve this issue, we can do the following. While compiling the final exe file, we can add a 32-bit unsigned integer at the end of it. This integer will contain the offset to the start of the data in the exe file. This way, when the game initializes the data, it will go to the last 4 bytes, read the offset, go to it, and start reading the data from there. After the final exe file has been compiled, the temporary file is no longer required, so it will be erased. Furthermore, when compilation steps are done without any errors, it automatically launches the final exe file. For now, it's just a black screen because engine is still under serious reconstruction, and I am only interested in it running without crashes after the compilation for now. Audio took a lot of attention from me this month. I started reorganizing the whole audio source code and fully rewrote the audio renderer, providing it a new feature, arpeggios. The way I make audio is manipulating 8 channels that can play only one note at a time. Arpeggios allow one channel to play a chord by quickly switching from one note to another. The result sounds like this. The reason why I decided to implement this is because I heard a lot of 8-bit VRC6 covers on YouTube that use this technique, and I really like it. I believe this will allow me to make better soundtracks for my game. Speaking of music and sound creation, I decided to stick to writing text SAF in Notepad and then converted it into byte SAF using the compiler, but I did some changes to the workflow. First, before I start making or editing the text SAF, I launched the SAF compiler. This compiler checks folders with music and sounds every second, searches for the last updated file, and compares its last modified time with the time it last compiled something. If the file's modified time is later, it's going to save this time for future comparisons, compile this file, and put it right into the assets folder following its exact path and creating missing folders. Now, the data compiler will include it next time it's going to be called. Furthermore, it uses this compiled SAF file and creates playable WAV file from it, so I can listen to how the music will sound like when it is being played in the game. After generating this WAV file, it immediately opens it. This results in the following. Every time I save a text SAF, it compiles it into the correct location, generates WAV file, and opens it so I can hear how changes that I made affect the song. It saves a lot of time and even allows me to switch files I work with in Notepad. I think that's all for sound creation. I'm not planning to edit it anytime soon. Speaking of audio, I'm not even finished working with that. To describe what I am dealing with right now, let me show you how audio in programs and games work. You create audio blocks, write data into them, and then send them to the audio driver. Once it's pushed to the audio driver, it starts playing it. When the block has finished playing, the audio driver notifies you about it, so you can rewrite the data on this block and push it back to the end of the audio block queue. If you are going to use only one audio block, it's going to result in unpleasant gaps because when the block finishes playing, nothing is going to play until you do all the required steps to push it back. This is how it's going to sound like if I played my voice like that. Not really pleasant, is it? Therefore, I need to use multiple audio blocks if I want the audio to work properly, but it also adds more complication to the essential mechanic in my game, syncing. I will need to synchronize sounds with the music, but this is not really a big problem because I just need to check the position of the music that was last written to the driver and start writing sound samples in the correct positions. However, visual syncing is much more complicated. The visual syncing means placing objects according to what the player hears currently, rather than refer to the last sample that was pushed to the driver. As I mentioned earlier, once the audio is pushed to the driver, it begins to play it. Therefore, you need to calculate time intervals in order to get it right. However, there may be gaps if for some reason audio blocks is loaded in late. This will cause serious desync. And I am not even mentioning the intentional delay because sounds must go slightly behind what we can see. The reason for this delay is due to how physics work in real life, but I'm not going too deep into that. I am still thinking of an efficient way to implement the audio synchronization and planning on explaining the solution I will come up with in my next devlog, but for now, I would like to finish on this note. Sorry if a lot of stuff in there was too complicated or confusing. Hopefully, the fun part of the game development will start soon, so I will have much more understandable information to provide. Thank you for your time. See you later.